Ever wondered how the world of mathematics predicts and analyzes regularity? Enter the equilibrium state matrix. This intriguing tool is a part of the broader family of state matrices, which essentially represent the state of a system at a specific point in time. You can think of a state matrix as a snapshot, capturing the current state of affairs in a mathematical system. Now let's add a dash of regularity to the mix. When we talk about regularity in transition matrices, we're referring to a situation where there is no significant change from one state matrix to the next. It's like taking a series of photographs, where each picture is almost identical to the one before it. So what happens when these two concepts meet? They give birth to the equilibrium state matrix. This is a state matrix that remains unchanged over time, thus achieving a state of equilibrium. And so the equilibrium state matrix becomes our mathematical crystal ball, predicting the future state of a system. Now that we understand what an equilibrium state matrix is, it's time to learn how to identify it. First things first, we need to define our initial state matrix. This matrix represents the starting point of our system, with each element representing a different state. Let's say we're looking at the weather. Our initial state matrix might include the probabilities of it being sunny, rainy, or snowy on a particular day. Next, we have the transition matrix. This matrix shows the likelihood of transitioning from one state to another. Sticking with our weather example, the transition matrix might show the probability of going from a sunny day to a rainy day, or from a snowy day to a sunny day. Now here comes the interesting part. We multiply the initial state matrix by the transition matrix to get the next state matrix. This new matrix gives us an updated representation of our system. If we're talking about weather, our next state matrix could show how the probabilities of it being sunny, rainy, or snowy have changed after one day. But we're not done yet. We need to repeat this process of multiplying our current state matrix by the transition matrix. We do this over and over again, updating our state matrix each time. How long do we continue this process? Well, until our state matrix stops changing significantly. This is where the concept of equilibrium comes in. If the state matrix doesn't change much from one step to the next, it means we've reached a stable state, or an equilibrium. This is our equilibrium state matrix. In our weather example, the equilibrium state matrix might show the long-term probabilities of it being sunny, rainy, or snowy. It's the state that our weather system tends to settle into over time. With these steps, one can identify the equilibrium state matrix, a key tool in understanding the long-term behavior of a system. Let's take a moment to recap what we've learned about equilibrium state matrices. We started our journey by introducing the concept of an equilibrium state matrix, a fascinating mathematical construct that remains constant or shows no noticeable change from one state to the next. These matrices are the steady states of a system, the points of balance where everything seems to settle down. Imagine a juggler juggling balls in a steady rhythm, or a pendulum swinging back and forth in a predictable pattern. That's the magic of equilibrium, a sense of consistency and predictability in a world often filled with random fluctuations. We then delved into its role in analyzing the regularity of transition matrices. We saw how an equilibrium state matrix is instrumental in sifting through the chaos and finding a pattern, a rhythm, a regularity. It's a bit like a detective, piecing together clues to form a coherent picture. But instead of solving a crime, it's solving a mathematical puzzle, revealing the underlying regularity of a system's transitions from one state to the next. Finally, we walked through the process of identifying an equilibrium state matrix. We emphasized the importance of this process, not just as an abstract mathematical exercise, but as a real-world tool for understanding and predicting the behavior of various systems. Whether it's the stock market, the weather, or the spread of a virus, the equilibrium state matrix can give us a glimpse into the future, allowing us to anticipate and prepare for what's coming. In a nutshell, the equilibrium state matrix is a mathematical microscope, letting us zoom in on the intricacies of a system's dynamics. It's an interpreter, translating the complex language of mathematics into something we can understand. And it's a fortune teller, giving us a peek into the future based on the patterns of the past.